Okay, recently we were given an assignment for Chapter 3 for you to take an electrical diagram and convert that into a PLC program. And what I gave you was just a worksheet for you to kind of make note of your addressing and your instructions and then the way you relate your instructions together. So what I'm using a PLC programming simulator called Logix Pro. So I'm going to create this very quickly and kind of show you one way to do it. Keeping in mind that there's multiple ways to program anything. So yours won't necessarily look exactly like mine. So I'm going to start out just looking at the first two rungs that we have in the electrical diagram. We know we have just a regular start-stop station that's going to energize a control relay and a pilot light, and it's also going to have a seal-in. Keep in mind in the PLC equivalent, we're going to be able to eliminate the CR1 and the CR2 because these control relays are just used to create condition for control in an electrical diagram. So the addressing is going to be a little different compared to what we're using in Compact Logix. I'm going to start out with my stop push button, which we know is always an XIC instruction. And the very first address in this PLC programming scheme is going to be input:10. So I've given it an address and I've already given it a name. So this is my stop push button. So next I want to create a start push button. So I'm going to select here. And this address is going to be input:10. Well, it's actually going to be input:11, which I've called start push button. So after that, I know that if I press the start push button, I want to be able to energize my CR1 and my pilot light. So I'm going to create an address, an output address, and it's going to be an internal address, internal instruction that I'm just going to use to create this condition. So this is going to be my my very first one. In this addressing scheme, I'm going to have to use B3 for an internal bit, and it's going to be 00. And I've given that a name of condition 1. So I've created these titles beforehand just to save us a little time. So I'm going to use this to seal in around my start push button. So in this case, I'm going to create a branch. I'm going to drag my input instruction in. And this again will be an XIC input instruction. Then I'm going to give it the same address as my B300. So when I do that, I'm going to drag the address over. Now I've got a condition that when I press the start push button, my output will energize and I'll be able to seal it in. If I look at my electrical diagram, I also want to seal in a pilot light. So I'm going to create that over here, keeping in mind that our outputs can go in parallel and never in series. So I'm going to create another branch instruction. I'm going to create a new output instruction that I've already addressed earlier, but this is going to be, in this scheme, is going to be an output 20, and that is my PL1. All right, so if I want to go ahead and try this, I can download it and test it. So I'm going to download the PLC in my simulation. I'm going to select Go Online, and I'm going to run mode. All right, so let me hit stop, start it over. So my stop push button is already pressed. If I press it, obviously it goes away. If I press and release my start PB, and this is my input-output simulator over here, press it, I've energized my condition 1 and also PL1, which I see energized over here. So I'm going to go ahead and stop that, and I'm going to go offline now. To keep track of what we're doing over here, I'm going to just create a couple of stars by every instruction that we've already created, that we have an equivalent electrical component for. That'll kind of keep us on track. All right, so if I'm looking at the next rung, we've already created an equivalent PLC program for all of this. The next rung has a normally open pressure switch. I also have a contact. If you notice, this contact is going to be true if CR1 is energized, and then in turn will energize a solenoid 1 and create another condition based on CR2. So it's actually going to be a little simpler than my electrical diagram. I'm going to create, let's see, an input instruction, first of all, for my PS1. And I'm going to use the address input:12. And that's PS1. And what I'm using a toggle switch just to simulate the action of my pressure switch. The next instruction in my rung is actually going to be another input instruction related to my condition 1 that I've already created. Because if you notice that this is CR1, this contact is labeled CR11, CR12, so both contacts are associated with that control relay. So I'm going to create another input instruction, and it's going to have the same address of condition 1. If these both conditions are true, I want to be able to energize the solenoid 1 and then also another output instruction. So I'm going to do the solenoid 1 first, and this output is going to be output 2 colon output, excuse me, output 2 1. And that's my solenoid 1. But I also want to engage another instruction of an output instruction. I'm going to have to create a branch for this so that it will also go true under this condition. I used B300 already, so I'm going to use B301 for this one. And I've given a description of condition 2. So over here I'm going to go ahead and create some notes so that I'll know that I've already programmed all of these devices in my program. All right, so now I have a condition that if I press the start push button, condition 1 will energize, pilot light 1 will energize, and then if pressure switch closes, I'll be able to energize solenoid 1 and also create an output condition 2, which will also be true. So I'm going to create another rung, and we want to take a look at the next rung. If you notice this limit switch 1, there's only one limit switch, but we're using 2 contacts with it. And it shows a mechanical linkage between the contacts. So that says that if the limit switch is activated, this contact will close, but a separate contact will open. So let's just take a look at this rung to start with. I'm going to create an input instruction that's going to be associated with limit switch 1's normally open contact. And I'm going to give that an input instruction, input 1, 3. Well, let me give it a 3 instead of a 2. And that is limit switch 1. And I'm going to change this symbol because this is limit switch 1, switch 1. Remember, there's 2 switches in this limit switch, and I want to make sure that I understand that I'm going to program each one separately. Limit switch 1, switch 1, and then I have a contact associated with CR2. Well, in my PLC program, I've already created a condition 2, so I'm going to create an input instruction with that address. So if both of these instructions are true, since they're in series, I want to energize a solenoid 2, which is going to be an output. And the output instruction, the next address I have available is output 22, and I've already called it solenoid 2. All right, so that's actually looking pretty good. I'm going to download this very quickly, and we'll test out what we've got so far. All right, so if I press start push button and release it, I've energized PL1, and I've also set the condition for condition 1. So condition 1 is true. If the pressure switch 1 closes, which I'm using input 1, 2, solenoid 1 energizes. I've also enabled condition 2. So if the limit switch is activated, switch 1 on that limit switch will close, and I'm using input 1, 3, and that's going to energize my solenoid. If I hit the stop push button, then everything de-energizes because I've lost the conditions. So I'm going to go ahead and open pressure switch 1 and the limit switch. Let's go offline and we're going to do the last rung. So this is a little tricky because if I think about it, I got to think about it in terms that I have 2 distinct separate switches inside of this limit switch. One is normally open and one is normally closed. So I'm going to use another instruction, an XIC instruction, and I'm going to give it a separate address because it is a separate contact. And I'm going to call this one input 1, 4. And I'm going to change the symbol to limit switch 1 because it is, but this is switch 2 inside of that limit switch. So the contact says if the limit switch is not activated, this contact will be closed. If this contact is closed and the selective switch is selected and CR2 is not energized, then I'm going to be able to energize solenoid 3 and pilot light 2. So the next instruction I want to go ahead and create is for my selective switch, which is normally open. And this is going to be input address input 15. And I'm going to give it an edit symbol of SS1. And I also have to consider that this instruction, condition 2, has to be false in order for the rest of the rung to be true based on this contact status. So in this case, I'm going to use an XIO instruction with that same address. And then I'm going to just put in output from a solenoid, which is going to be solenoid 3. And this is going to be output instruction, output 3, solenoid 3. And also, I want to engage a pilot light. So I'm going to have to create a branch instruction, another output instruction, and I'm going to give it an address, output 24. And output 24, the pilot light 2. All right, so let's test this very quickly. I'm going to download it again. I'm going to go online and run. All right, so if you notice the last condition, the limit switch is not activated. So this instruction is true because I'm looking at the switch 2 and that limit switch. My condition 2 is not true, which means that this input instruction is true. I can energize my solenoid 3 on the pilot light by simply selecting the selective switch associated with input 15, which is here. If I choose that position, solenoid energizes and the pilot light energizes. So I'm going to take that selective switch back to off. I'm going to start at the very beginning. I'm going to press the start. To start, condition 1 now is true. Pilot light 1 is energized. Condition 1 input instruction is true. So if I close the contact associated with pressure switch 1, solenoid 1 energizes, and I've also set up for condition 2. What's going to be interesting is that for solenoid 2 to energize, the limit switch is going to have to be activated. When I activate the limit switch, it does close, but I have to keep in mind that this contact actually opens because they're linked together. And I just have to do that in my simulation. So if the limit switch is activated, there's no way that solenoid 3 will energize because my condition is actually true here. All right, so I'm going to turn everything off. So this is one way to create the program. If these were not linked, you would be able to use an XIO instruction and use the same contact. But since these are linked, keeping in mind that you have 2 separate limit switches, one limit switch with 2 contacts. So hopefully you found this useful. And your program may not look similar to this, but it should work. All right, thank you.